Hi everyone, I'm very glad to discuss the section I read from the Introduction to Probability Models 11th edition. In this section, it introduced a regenerative process and an alternating renewal process. But before I explain these two processes, I have to give a brief talk about the renewal process because the renewal process is very elementary for these two processes. The renewal process is a counting process that the time between every event has identically independent distribution. It can be obviously shown by the picture. From the picture, we can understand that a renewal process is a sum of jump time. And for example, the sum of two time intervals means the renewal process occurs twice. And it is defined that once a renewal process occurs, it forms a completed cycle of regenerative process. Now let's begin to talk about the regenerative process. According to the definition, the regenerative process has identically independent distribution at every time interval. So in other words, in different time interval, a regenerative process has same probability to enter a same state. The process have the property that there exists time point at which the process restarts itself. So we can get the conclusion that if a renewal process happens at time t1, now the renewal process can be considered as a regenerative process. And the property also follows the property of a recurrent Markov chance. In a recurrent Markov chance, the probability that you will return to any given state at some point after visiting it is 1. This means any transition into the initial state has the same distribution. They restart from themselves. So a recurrent Markov is regenerative. To calculate the long-run time a regenerative process spent in any state, we need to use the property of a reward renewal process. The renewal reward process is under the assumption that we get a reward after a renewal occurs. And in this formula, we use Rn denote the nth reward we get, and Nt is the renewal process. So we can induce that Rn is highly related to the time intervals of a renewal process. So we can conclude that the expectation of long-run reward equals the expectation of a reward in one renewal process divided by the length of a renewal process. In another word, it can be explained by expectation of reward and during a cycle divided by the expectation of the length of a cycle. Now, let's back to the regenerative process. Since the regenerative process is a special case of renewal process, as we all know, the cycle of the regenerative process is related to the renewal process. So, to calculate the long-run expectation, we can use the renewal reward process as well. In that case, we should assume that we can get one reward when the regenerative process is spent in a state. So by applying the renewal reward process, we can calculate the expectation of long run time of the regenerative process spending in a state equals the expectation of the amount time in a state divided by the expectation of the length of a cycle. Now I will introduce another example of a regenerative process, which is known as an alternating renewal process. The alternating renewal process has a system that can be in only two states, on or off. Initially it is on, and it remains on for a time, and then it goes off and remains off for a time, and then it goes on for a time, then off for another time, then on, then off, and so on. Since then, we can easily calculate the expectation time of the process at state on or state off. P on is denoted the long-run proportion time that the system is on. That equals the expectation time when the system is on in a circle divided by the expectation time of the circle. Since the alternating renewal process is a kind of regenerative process, so here we can use the theory we derived from the regenerative process. Now I will introduce an interesting property of the alternating renewal process. That is called age and excess life. Just explaining the theory literature is a little difficult, and the theory itself is a little tricky, so I will show you a picture to help you understand it. From this picture, we can understand that the horizontal axis means the time of the process. And we defined the age at time t as AT equals the amount of time elapsed since the last renewal, and the excess life YT is the time until the next renewal. When you look backward, these two values represent a same time interval. This is the briefly explanation of the age and the excess life. Now I will give you an example in our real life to show how the alternating renewal process works. Suppose there is only one ATM in your W campus, and one day many students want to withdraw their money. However, the machine can only serve one person at one time. So when a student is operating the machine, the others have to wait until he finished until he withdrew the money. Suppose the time spent by students at the machine is 2 minutes with exponential distribution, and the waiting time for every student is normal distribution with a mean equals 3 minutes and a variance equals 1. Then these two distribution will form an alternating renewal process. The relationship is as follows. We can calculate the long-run expectation of waiting time. It equals the expectation of waiting time of a student divided by the cycle time. Hereby, we should notice that when a student is operating the machine, it means this time is also should be calculated as waiting time for other students. So we use 3 plus 0.5 divided by the 3 plus 0.5 here. And the outcome is 1. I think the outcome may be not very practical, but this example makes sense. Finally, I will talk about the renewal equation and the renewal function. Although they are not in the section I read, they are key ideas of renewal process, and I have to apply them to solve the examples in my report. So I think it is necessary to introduce them. Now, let me start from the renewal equation. From this picture, we can know, according to the definition, we can calculate the mean value of NT. Please remember, NT means the renewal process, and the function MT is known as the renewal function. It can be shown that the renewal function MT determines the renewal process. Specifically, there is a one-to-one correspondence between the interval distribution f and the mean value functions MT. Please note that the xi is a random variable, and it is independent and has a common distribution f. It follows that Sn equals the sum of xi, and it is distributed as Fn. The Fn here is a n-fold convolution of f with itself, but the definition of convolution is beyond this chapter, so I will omit in this video presentation. Anyway, we can get the formula here. Now, suppose that the first renewal occurs at time x that is less than t. Then, using the fact that a renewal process starts over when a renewal occurs, it follows that the number of renewals by time t would have the same distribution as 1 plus the number of renewals in first t minus x time units. Therefore, we can get this formula. This MT function is called the renewal equation, and sometimes it can be solved to obtain the renewal function. I will specifically explain the one. Because a renewal occurs at time x, it means There must a renewal occurs at previous time. So the probability of the previous renewal must be 1 because it has happened.